Hello, my name is Mr. Rogers, and you are watching the video lecture for Section 2-4. This is on covalent bonds. So we're talking about bonds, James Bond. So maybe I should talk in my best James Bond accent. I don't have a very good James Bond accent. So show me your best James Bond accent when you come into class tomorrow. Mine's terrible. I do the old Sean Connery, James Bond. You guys can do better. So when you come into class, let's see who has the best James Bond impersonation. All right. So today, guys, we're talking about covalent bonds. I guess I should stay on this slide here. And this first page, again, you do not have to write anything down. This is our lesson objectives page. And our one objective for today is to describe how covalent bonds form. That's the only thing we're focusing on today. So, simply put here, guys, covalent bonds, they happen between two nonmetals. So a nonmetal atom bonds with another nonmetal atom. Now, this is different than a ionic bond, which is between a metal and a nonmetal. These are just in that more the right side of the periodic table are nonmetals. So what happens here, the atoms share their valence electrons with each other. Because neither is strong enough to pull the electrons away from each other, they tend to kind of be locked in this epic tug of war. And they're both pulling on these electrons. They want them, but there's kind of this equal sharing a lot of times, sometimes unequal, but we'll focus on the equal sharing, and we create these covalent bonds. So they're not typically as strong. Sometimes they can be broken with less heat than ionic bonds. But they are formed because they're sharing electrons now. So covalent bonds, they're covalent, they're sharing. Like if you have a position, it's the co-president. There'd be two people sharing that position. Covalent, those covalent bonds are sharing electrons, sometimes more than one. So on the periodic table, these nonmetals. So our nonmetals tend to be more, yeah, over here. So it's kind of our purple is that line right there. Back up around there. Those are our nonmetals. Also, if I come over here, hydrogen, it's a bad circle, is a nonmetal. So those tend to be the elements that we find they're going to form to make these covalent bonds, or nonmetals. And so what happens is, let's jump ahead here. Atoms are going to be sharing electrons. So, for example, and actually I can take hydrogen, my first example, and do it that way. I'll kind of rotate hydrogen around so it's upside down. And so what happens here, and this is typically how hydrogen appears in nature too. It's always H2. I think you've seen that in some of the formulas we've done before. So because hydrogen needs to get that two valence electrons, it wants to get that outer shell happy, it needs to get those two valence electrons. And so what happens here is these electrons tend to, see where I'm at here, yeah, they tend to share. So we'd kind of draw a circle around that showing where the covalent bond is between those two electrons. So we show the circle, and that shows that we are sharing electrons. That is what that shows. So sometimes, I'll erase these out here. It can happen differently though too. So let's bring in oxygen. Let's bring in oxygen here. So oxygen, again, we need to get 8 valence electrons for oxygen. So as right now it has 1, 2, 3, 4, 5, 6. So bring one in right there. Bring one in over here, and again we'll spin it around. Make it fit a little easier. There we go. And so I have it over here. So now my two kind of areas here. Oh. So there's, I'm going to circle those, they're sharing those. And then over here we are sharing those two. So in this case, we have oxygen is going to share one atom, or one electron, with this hydrogen atom. So now hydrogen has its 2, so it's happy. And now oxygen has its 8, it's sharing 2 other hydrogens to get to its 8 valence electrons. So let's try this with another one here. So how about just oxygen itself? Sometimes And so for this one, sometimes you need two, sometimes you need three, sometimes it depends on how many it needs to fill that outer shell. So here we have hydrogen. We'll twist it around, make it fit here. Right there. One right there. One right. Oh, almost got it. One last one. So now I have, again, I want that outer shell to be 8 for carbon and 2 for hydrogen. So there's this guy sharing those two. We're sharing those two. We're sharing those two. And we're sharing those two. So you can see now carbon has its 8, 2, 4, 6, 8, and hydrogen, each one has 2, so it has that outer shell filled. So again, our biggest goal is to fill that outer shell. So to recap, guys, covalent bonds are between two atoms or more, and they're sharing those valence electrons. They're not gained or lost, they share them, sometimes unequally, but mostly we'll focus on the equal type. They share the electrons to get their full outer shell of valence electrons to be happy. So we're going to stop there. I thank you guys for watching, and have a good day.